All right, something to remember again is you may do it a different way, and that is no problem at all. So this one, number 9, 1 on cos, we know is the same as sec. Third letter of sec is C, so 1 on cos is sec. So 1 on cos squared is sec squared theta. And 1 on cot is tan, so 1 on cot squared is tan squared theta. And remember the identity, 1 plus tan squared theta is sec squared theta. So I'm going to change sec squared theta to 1 plus tan squared theta. I'm subtracting that tan squared theta. So these two, tan squared theta minus tan squared theta, that cancels and I'm just left with 1. All right, let's look at number 10. So number 10, if we multiply cos times sec and then cos times minus cos. Okay, we'll do that first. So we have a cos theta sec theta minus cos times cos is cos squared theta. Now remember sec theta is 1 on cos theta. And so we're going to have a cos cancelling with a cos there, or cos on cos, which is 1. So we've just got 1 minus cos squared theta, and we know that that is sine squared theta, because remember, sine squared theta plus cos squared theta equals 1. So if we keep sine squared theta by itself, we're subtracting cos squared theta from both sides. Okay? Okay, looking at number 11, we want to do the same thing here. So again, so many different ways to do it. You could, if you want, anyway, you could change sec squared minus 1 and put it in terms of tan squared and then in terms of sine on cos. Or we could just use the reciprocal nature of it and say, let's just times it out first. So we've got that one times that one and that one times that one. And just remember again that sec is 1 on cos, so sec squared is 1 on cos squared. Did we just do this one? Feels like it. So you keep coming across the same identities. So cos cancels, so it's just cos squared on cos squared, which is 1. And we've got minus cos squared a, and we know 1 minus cos squared a is sine squared a. Again, using our Pythagorean identity, sine squared plus cos squared equals 1, but rearranged. Now number 12, what we can do here is a couple of things. For example, it really doesn't matter which way you do it, but say we just multiply out the first two brackets first. So you'd get 1 times 1, 1 times sec x, negative cos x times 1, negative cos x times sec x. So negative cos x times sec x. And all of that we still need to times by cos x. Okay, now we know, well, let's do this first. In here we can see that cos x, sec x is just 1 on cos x. We know that one. And we know that then that cancel, well, just gives us 1. So we've got 1 minus 1. We should show it because it is a show that. So we're going to end up with 1 minus 1 inside that bracket. So the only thing that will be left, did I change that to a minus when it should be a plus? I did. Alright, so the only thing left then will be sec x minus cos x. And we're timesing it by cos x. So what do we have? So again, sec x, I should have changed already. So our sec x is 1 on cos x. I might just put that in, putting a lot of extra in here. Before I times by cos x, I'm just going to go over here. So you can see when I times that by cos x, I will get cos x on cos x. When I times this one, I'll get minus cos squared x. So I'm getting 1 minus cos squared x, which we know is sine squared x. We keep getting that one. So again, you could skip a few lines, but be careful because it is a show that. So we need to make sure we provide, all the basic steps. So it's good to have more steps and less steps, just to show what you're doing each time. All right, let's look at 13. So here we've got a sine x, we've got a cos x, And we've got a 1 minus cos squared x, which we know we keep getting is sine squared x using our Pythagorean identity. So one of the sine x's cancels from top and bottom, and you're left with a cos x on a sine x. Again, we know this ratio is cot x. So sine on cos is tan x, cos on sine, cot x. All right, and number 14, oh, a nice one here. Again, do it any way you like, as long as we get there. So I like to change tan squared, remembering that, I'll write it over here. 1 plus tan squared x is sec squared x. So in this case, tan squared is going to be sec squared minus 1 if I rearrange that. So I'm going to change that to sec squared theta minus 1 on sec theta plus 1, and then you've still got the plus 1 there. Now that is the difference, that top bit there is the difference of two squares. How do you factorize the difference of two squares? You sec theta minus 1, sec theta plus 1. And remember on the bottom we've got sec theta plus 1. So those sec theta plus 1s are going to cancel, common factor. So what have we got left there? We've got a sec theta, and we've got a minus 1, and then we've got over here a plus 1. So the only thing left will be sec theta.